Imagine the world in 2050. It's fully electric. Our cars, our heating, our industries. But there's one massive problem. Our current power system wasn't built for this. It's old, centralized, and reaching its limits. If we don't adapt, the system will fail. IDEAL4GREEN is building a new generation of researchers and engineers to help to build a greener, more sustainable future by the help of microgrids. When we applied for this project, we had a vision. This vision was to help to electrify the world. We have still 800 million people on the world without access to electricity. And we need to make this project in order to help people to access electricity.
So the conventional system has been designed in a way that we have very large plants, and these plants distribute the energy across a large area of territory through first transmission lines, which are high voltage lines, to the final user. This is not the optimal way to supply a specific territory that is isolated of this main system and that could have limited resources to develop such infrastructure.
How we fix it? By thinking small to big. We need microgrids. Imagine breaking the massive grid into independent, self-sufficient energy islands that are smarter, greener, and more reliable.
A microgrid can be understood as a system that uses, let's say, renewable energy sources like PV to generate energy and to supply a small amount of demand. Differently on the design of the conventional system, where it follows a top-to-bottom approach, where we have big plants, then transmission lines, and then we step down to the final user, these systems can be built in a bottom-up approach.
The challenge in IDEAL4GREEN is to bring the concept of microgrid to a next level. IDEAL4GREEN tries to build a grid of microgrids that are connected together, that are helping each other in order to build a more reliable and more economic system.
The concept of microgrid or mini-grid can mean different things. There are systems that are very small and supply a couple of households, whereas there are other systems that are much larger and they will supply big loads from agriculture or from other forms of productive uses of electricity.
Basically, the difference between a microgrid and a nanogrid is in terms of size. A nanogrid is an installation that can also operate grid-connected and grid-isolated, but would be in the power rating of less than 100 kilowatts. While microgrids can have larger sizes, larger extension, and therefore more assets connected, and has more power rating. So it can go from hundreds of kilowatts until tens of megawatts.
So delivering this vision, I think, will happen through different pathways. In places like in Europe and places where I have established power system, what can happen is that existing parts of the network can be turned into microgrids or mini-grids. And this is something that is already happening, for example, with systems that require high reliability, such as data centers or banks, hospitals. In other parts of the world where there is no transmission system or the system has to be built, it's going to be the other way around. It's going to start with mini-grids being built that then later linked together and connected to the national grid when it becomes available. And this is a completely different paradigm of developing the power system, and it's something that we haven't seen before.
The keys of success, from my point of view, for rural electrification are various. To enhance the quality of life of the people is related to, let's say, 4 keys of success. First is sociology. You cannot think about a solution to empower a community that will fit for all the communities at large. Second is economy. You have to make sure that what you are bringing is at the correct price for the kilowatt hour, the electricity that you bring. The third point is about capacity building. You need to make sure that people will be able to use, repair, maintain on the long run. And the fourth point, from my viewpoint, is you have to think about industrialization. You cannot just make something that will be for a specific communities, and that's it. You have to think on mass market. You have to think about something that will be affordable, that must go through standardization. So sociology, economy, capacity building, and standardization.
The society will benefit from the results of IDEAL4GREEN by having new technology available and bringing more prosperity to both the society and the scientific community.
Part of the electrical power transformation is being driven by 3 Ds: decarbonization, decentralization, and digitalization. And I think that IDEAL4GREEN, with this support to microgrids and nanogrids deployment, is pushing 2 of the Ds: decarbonization and decentralization. Digitalization, the 3rd D, can offer a lot to microgrids and to nanogrids, but as we are thinking in rural areas or in areas that have little electricity access, probably the sensing and metering is also scarce there, and there's still a lot of investment to be done if we want to exploit the data being generated in these installations.
Layer of digitalization should be maybe the most important point to measure in the future, and how to connect the traditional world and the future on digitalization. And it's really a challenge for all of us, not only manufacturers, but also academia, and how to work all together.
I started my microgrid research from 2014, and I'm quite excited to see that microgrid research from this past more than 10 years that attract increasing attention and more real-world applications, and how microgrid nowadays recognized as the building blocks of future smart grid, and in different like industrial applications and buildings, energy communities, smart cities, e-mobilities, different kinds of applications.
To build this future, we need the best minds. That's why we have selected 15 brilliant doctoral candidates from all corners of the globe. Their mission over the next 3 years to reinvent how we distribute energy. And it starts right here, right now. We have united them at IDEAL4GREEN together with 20 top institutions.
IDEAL4GREEN, being a doctoral training network, it permits doctoral students to gain knowledge and develop solutions in an interdisciplinary environment where they can gain expertise and insights not only from academia, research centers, but also industry. And at the end, this triangle between research, industry, and university is essential if we want to boost knowledge to the extreme and to all the possibilities they can offer.
In such kind of project, we need the theory, and we also, and it's extremely important, as that's my role in the project currently, to have some experimentation. And experimentation without theory is meaningless. If you have theory only, you need some experimentation to be sure that what you discover, what you are looking at, will apply to real condition for the end users.
The network week is very important because it enables to build a network, a doctoral network, to really get to the next level of collaboration and building strong links between all the institutions and individuals that we have in the program.
Networking weeks are super useful for both the industry and the PhD students as well. A lot of times what happens is that we tend to work in silos and we don't discuss ideas with each other. So this networking week provides you the perfect opportunity to discuss everything, how the different companies are approaching, how different students are developing certain ideas. And it's also preparing the students to present and articulate whatever they're working on, which is something is always a challenge for engineers. And we are not always the best to present the works we are doing. So it's a perfect opportunity for everyone to, work together and mingle together.
IDEAL4GREEN, in a sentence, if I'm able to summarize it, grid group, grid consortium, grid coordinator, to achieve great results in the empowerment of people. Let's not forget that more than 700 million of people don't have access to electricity.
We are turning research into reality. Welcome to Ideal for Green.